Liquid nitrogen facts. Liquid nitrogen is liquefied from of the element nitrogen that's produced commercially by the fractional distillation of the liquid air. Like nitrogen gas, it consists of two nitrogen atoms sharing covalent bonds. Sometimes liquid nitrogen is denoted as Ln2, Ln, or Lin. A United National number UN or UNID is a 4-digit code used to identify flammable and harmful chemicals. Liquid nitrogen is identified as UN number 9077. At the normal pressure, liquid nitrogen boils at 77 K minus 195.8 degrees Celsius or 320.4 ppm. The liquid to gas expansion ratio of the nitrogen is 1 to 694, which means liquid nitrogen boils to fill a volume with the nitrogen gas very quickly. Nitrogen is non-toxic, odorless and colorless, is relatively inert, and it's not flammable. Nitrogen gas is slightly lighter than air. When it's reached to room temperature, it is slightly soluble in water. Nitrogen was first liquefied on April 15, 1883 by Polish physicians Zygmunt Obolski and Karol Olszewski. Liquid nitrogen is stored in a special insulated container that are vented to prevent pressure buildup. Depending on the design of the Delaware flask, it can be stored for hours or for up to a few weeks. Liquid nitrogen container may accumulate oxygen that is condenses from the air as the nitrogen evaporates. That's a risk of the volatile oxidation of the organic matter. Liquid nitrogen safety. When working with the liquid nitrogen, taking safety precaution is paramount. Liquid nitrogen is cold enough to cause severe frostbite on contact with the living tissue. You must wear proper safety gear when handling liquid nitrogen to prevent contact or inhalation of the extremely cold vapor. Cover an insulated skin to avoid exposure. Because it's boiled so rapidly, the phases transition from the liquid to gases can generate a lot of the pressure very quickly. Do not close liquid nitrogen in a sealed container, as this may result in it bursting or an explosion. Adding a large quantity of the liquid nitrogen to the air produces a relative amount of the oxygen, which may result in asphyxiation risk. Cold nitrogen gas is heavier than air, so risk is greatest near the ground. Use liquid nitrogen in well-ventilated area. Liquid nitrogen containers may accumulate oxygen that is condensed from the air as the nitrogen evaporates. There is a risk of the volatile oxidation of the organic matter. Liquid nitrogen uses. Liquid nitrogen has many uses manually based on its cold temperature and low reactivity. Examples of the common application include the freezing and the transporting of the food product, the cryopreservation of the biological samples such as sperm, eggs, and any animal genetic sample, use in coolant for superconductors, vacuum pumps, and other material and equipment, use in cryotherapy to remove skin abnormality, the shielding of the material from oxygen exposure, the quick freezing of the water or pipes to allow work on them when valves are unavailable, a source of extremely dry nitrogen gas, the branding of the cotton. Thanks for watching.